When you jump off, a mysterious force pulls you back to the ground. Why? This is the effect of gravity. Just because of effect of gravity, you fall down to the ground. Let's take an example. This is the matchstick box and I drop it and it's gone to the earth's surface. Why? Because a mysterious force called gravity is pulling this matchstick toward the ground. So with the help of this experiment, I can say gravity is a force which acts between two massive objects, or this is a pulling force, not a repulsive force. It is a pulling force which acts between two massive objects. And the matchsticks fall down because the matchsticks have less mass than Earth. So that's why Earth is stable here and the matchsticks gone pull to the ground. Okay, so what's the effect of gravity on a fire flame? Let's see. This is the fire flame. You can see it. And it is near in conical shape. Why it is so? Because gravity want to pull it down toward the earth. And just because of this, the fire flame is the fire flame width is more toward the lower side and sharp from the top side. Actually, we can feel the effect of gravity. We cannot see gravity, we cannot touch gravity, we cannot feel gravity. So it's coming non-matters. By the way, Sir Isaac Newton and Einstein both have different definitions for gravity. According to Newton, gravity is the pulling force which exerts between two massive objects. Any object which have mass have gravitational force. If I am standing on the earth, it's just because I am having mass and earth having mass, and earth and me have gravitational attraction between them. And there is a misconception. People think massive object exert more force on less mass object. Just take an example. This is the matchstick and this is the heavy box. The force, the gravitational force which exert between these two things will be similar. The matchstick will apply same force on this box and this box will have the same force on this matchstick. Not such thing. This is bigger inside, have more mass, will apply more force on there. No. The force of gravitation between them is equal. Both apply same force. Okay, according to Einstein, the gravity is bending of space and time curvature. To understand the concept of Einstein, just take a look on this video.
It was a truly radical break from Newton. Think of this table as space-time, and think of these balls as objects in space. Now, if space-time were nice and flat, like the surface of this table, objects would travel in straight lines. But if space is like a fabric that can stretch and bend, well, this may seem a little strange. But watch what happens if I put something heavy on the stretchy space-time fabric. Now if I take my shot again, the ball travels along an indentation in the fabric that the heavier object creates. And this, Einstein realized, is how gravity actually works. It's the warping of space-time caused by the objects within it. In other words, gravity is the shape of space-time itself. The moon is kept in orbit not because it's pulled to the Earth by some mysterious force, but rather because it rolls along a curve in the space-time fabric that the Earth creates.
Okay, thanks for watching. In the next video tutorial, I will take a look on speed of gravity, how gravity acts, and some misconception about gravity. Bye bye.